most of what I wanted to cover, Shama already did that, so I'll try to be brief in my presentation. Just to take an extension from what she showed with versus what we can do to reverse the situation or some of potential solutions that we can come up with. So we already saw that in the country there is a large deficit or storage requirements across most of the places where there is high intense agriculture. So in this study what we are trying to show is, can the shifts in the cropping pattern be one of the solutions, thereby reducing the requirements for storage, or in other words, reducing the irrigation requirements for crops. So my talk is structured into 4 parts. I'll briefly give a quick motivation of the big picture scenario, and then we are looking into an exploratory optimization model that tries to shift the crop areas from one place to other, considering various constraints. And then I have very few preliminary results which I'll share with you, and summary and future directions. So the main motivation, as we already saw in the previous talk, is that India is facing a severe water stress, mainly owing due to the spatial and temporal resolutions in the rainfall and the current cropping patterns, which are really very unsustainable. Then we have already seen that areas with high intense agriculture have deficits which are very large, or these are in ways leading to groundwater depletions. So here we are trying to address a question that, can we somehow spatially optimize the crop choices in such a way that we can bring the water situation into a positive balance again? And the 3 main goals of this thing will be, we want to make sure that the food security is being met, that is, the total grains produced and total cereals produced or vegetables produced should be able to meet the whole country's needs. And then in addition to that, we want to make sure that the nutrition constraints are being met, not just calories, but a whole set of the nutrition requirements like calories, proteins, vitamins, so on and so forth. And then obviously we'll have a water sustainability constraint, which means that we want, for any given district or a small administrative unit, we want to make sure that the water supply in that region is enough to sustain the agriculture in that region under any situations. This is considering the spatial and temporal resolution of the rainfalls from daily to century time scales. Thereby what we are saying is, we are trying to come up with solutions such that the storage requirements are minimized or the irrigation needs under rainfall conditions are minimized. And finally, we'll have an economic sustainability constraint, which means that the cost of cultivation of these crops are spatially varying across different states and by crops also. And the support prices or the market prices for these crops are spatially varying. So we want to identify such a cropping pattern such that the national aggregate agricultural income is maximized. And to account for the growing population demands of the country, the National Food Security Mission has launched an initiative to increase the production of food grains by 10 million tons and pulses by 2 million tons in addition to what is being grown now by the end of 2012. So by doing this analysis, what we are trying to address is, at the national scale, what are the regions that and the cropping choices that can support this mission such that the area can be increased and we have an enhanced production of these crops in a very sustainable manner. And the previous studies on crop optimizations in India have focused at a command area scale or state scale and not really at the national scale. So, and we are also trying to incorporate the suitability or the feasibility of crops grown in a region by saying that given a particular type of soil or a temperature profile, what type of crops can grow in that region. And we also later want to include the constraints such that can we include cash crops like cotton, fruits or vegetables whose prices are fluctuating drastically, and can we include that in the model and still come up with the best solution. So this is a figure that Shama already showed, but here I am just showing the seasonal deficits, not the annual deficits. This is based on 12 crops, cereals, pulses and oilseeds in the Kharif season, and this is July, August, September, October, and which is the core monsoon season or the season where the country gets about 80% of the rainfall. So what we see here is that in Punjab, Haryana and the Indo-Gangetic plains, the storage required to meet the agriculture, this is purely based on agricultural demand. So this shows the storage required to meet the agricultural demands in these regions. So we can clearly see that in Punjab and Haryana, it's about at at least 1 or 2 years of annual average rainfall to meet that storage. And we can see the reasons for that. The rice which is being grown in most of the parts very intensely, that is greater than 75% of the net crop area is rice in these regions. And this figure also shows that rice consumes about 1.8 meters of water as opposed to the other cereals and pulses which are only 1/3 of those things. So what we are trying to come up is, can we shift rice to a different location which has high rainfall, and can we replace those things with other less water consuming crops like pulses or oilseeds. And just to motivate, this analysis is done only based on pure rain-fed conditions, that is, we are not providing any irrigation right now just to make sure that the groundwater depletion does not happen, and all these crops that will be grown is based on pure rain-fed conditions. So we are using a simple linear programming optimization model where the decision variables are the area that has to be grown for each crop under each district and for different seasons. Of course, here we are considering just the Kharif season or the rainfall season. And the objective function is to maximize the country's agricultural income in an expected sense, and where phi is the price per unit yield of that crop. And here the net, which is really the net income, that is the market price or the minimum support price that the government declares on a given crop minus the cost of cultivation for that crop. And yield is per unit area yield. This is obtained from the storage simulations upfront. What we are showing here is that under rain-fed conditions, if you know the seasonal deficits of any given crop and the crop water requirements of that crop, you can in fact get the yields under rain-fed conditions, comparing that with the potential yields. So under potential yields, we are considering the experimental yields, which means these are the yields that you can achieve under fully irrigated conditions. So under rain-fed conditions, if a region has high deficits, obviously the yields of that crop will collapse. So by doing this, we want to say that if you have a high deficit coming in from rice alone, we want to remove rice from that region. That's the idea. And the constraints that we are considering are the area constraints, which is the sum of all the crops grown in any given district or the administrative unit should be less than or equal to the net crop area in that district. So this does not allow for overcropping in any particular district. And then we have a food security constraint, which we are saying that we want to meet the total production of food grains, pulses, oilseeds, so on and so forth, to the target or the current productions or the target productions. And then in addition to the food security, we also have a nutrition constraint which says that we want to meet the target nutrition or the current nutritions that the country has based on a whole set of the nutrition requirements like calories, proteins, fats, iron, calcium, etc. And then we have a location constraint which says that depending on the soil type and the temperature profile of that region, is that crop suitable to grow there or not. So here we are showing the first cut results, and please note that all these results are purely based on rainfed and there is no irrigation provided. So on the left panel you see the current growing patterns of rice. So we can see that there is rice grown in Punjab, Haryana and the Indo-Gangetic plain. And on the right panel we see the rice given by the optimal solution. What we see here is that all the rice that is grown here, which is primarily based on irrigation, is being replaced under rain-fed conditions, even both in Punjab and in the Indo-Gangetic plain. And it is being put in regions where you have high rainfall availability, which is the core monsoon region. And these are the results of pulses, which are less water consuming crops. This basically consumes only 1/3 of the water that rice consumes. So what we see here is pulses which are currently not grown in Punjab and Haryana. The model is actually giving pulses which require less water. In fact, the model gives a lot of pulses which says that currently the country is actually importing pulses. But what we can show is under pure rainfed conditions alone, we really don't need to import pulses, or if we can somehow shift the cropping patterns, we can grow pulses in the country itself. So if you look at the case study in Punjab, it is interesting that historically Punjab has been growing pulses higher than rice, because this is the region where the Green Revolution occurred around 1960s. You can see that prior to 1960s, where the agriculture was purely rain-fed, people were growing pulses and less of rice, which is highly water intensive. So only about from Green Revolution, where the government started giving minimum support price and providing high-yielding variety seeds and all the irrigation requirements, free energy for irrigation, the people started growing rice highly because that fetches them more crop and the productivity is high there. And we can see that the pulses are drastically going up. So this kind of leads to a thought that people obviously knew what to grow from a very intuitive point of view. So I'll try to finish off with this figure that shows the storage requirements or the deficits from the previous existing patterns. What we see here is the figure that we saw before. That is the storage requirements or the deficits from all the 12 kharif crops in the country. And this is the storage requirements with the diversification of crops. We can clearly see that all the large requirements that the country needs to grow agriculture there is being replaced under the diversification of crops. So primarily this deficit is coming from the production of rice, and once we replace rice from that and try to put in some other crops which are less water intensive, obviously the storage requirements go down. So by doing this, we are saying that under pure rain-fed conditions, we can obviously sustain in any particular given district based on the rainfall that is occurring in that place. Some of the future directions that we want to take this is to, first we want to allow a water deficit constraint in such a way that we want to let that constraint decide the irrigation requirements of the crops. So by doing this, what we can also bring into the picture is the energy requirements for that irrigation and cost of providing that irrigation. That can be either through groundwater pumping or through surface water systems. And then later that can systematically lead us to what we can say that for any given district, if we have an energy constraint, we can compare that with the shadow price of what is the opportunity cost of that energy being provided for other purposes as opposed to water and agriculture. So this brings us to this water, energy and food allocation refinement scenarios. So just to finish up, what I'm showing here is purely based on rainfed scenario. And for experimental yields, we considered the yields that can occur under fully irrigated conditions in any given state. Obviously for rain-fed conditions, the yields for highly water-intensive crops will collapse. In the current potential, we could obviously see that the current potential productions under rain-fed conditions is being met for both cereals and other nutrition constraints. And so we believe that the water sustainability in India will be feasible. At the same time, we can provide positive economic returns and a positive water balance or reduction in the groundwater depletions. So obviously, one main concern is that this distribution and spatial pattern will drastically change the income distribution across the country because this is simply based on rain-fed irrigation. So we can also see that the national net agricultural income generated based on rain-fed conditions increased from $20 billion to $30 billion. So that is kind of a very good incentive. So then we can now include the irrigation requirements and try to increase the yields of any given crop in that district such that the district can have a maximum water deficit constraint. So with that, I'll take any questions. Okay, so here one of the constraints that we were considering is that the total food grains have to meet the current population needs or the current production of the food grains. So here by saying food grains, we were meaning rice and all the other food grains like maize, bajra and jowar and things like that. So obviously if people given those constraints, if people are willing to take any other crops or any other food grains, it can be met. But we can easily put in the constraint that we have to produce so much of rice because people really require that much of rice. And the hope is that we can still find a good solution under these conditions.
Yeah, it's kind of a follow-up question to what you just heard. If you can achieve the kinds of water deficit reductions that you're showing here with diversification, why isn't the government pushing this form of diversification? In other words, what stands in the way of realizing the patterns that you show up here?
I would believe it's really a big political game that's going on in the country right now. So there is this minimum support price and procurement policies for food grains, mainly because the country can have so much storage of food grains because they are non-perishable. And to really bring these things in, I don't know if, can you answer that question?
If I may answer, crop diversification has been proposed in 1960s, 1970s, and we have various committees that did crop diversification policies and they wrote reports. And farmers were also eager to diversify their cropping patterns, but they were not supported by the right kind of markets. So when the market collapsed, the market could not support the crop diversification strategy. And that is why, but recently there has been momentum and this push for crop diversification, even for some pilot places. They would not do it for the country as such, because obviously if they were thinking really hard, they would not be moving the rice to, the National Food Security Mission has moved rice to some of the eastern places. So it's after they did damage to the western part of the country, move to the eastern part, do damage there because there is enough water there. So obviously this plan, and those are exactly the kind of policies that we are trying to inform through our work. And the beef implication that you gave is actually high on the virtual water agenda, that it is higher up on the food chain, so there is more water consumption involved, and we do not have the right kind of data sets to do the virtual water for India as yet, though there have been other studies done in India, but those have been for very small places or they're very aggregated, not at the level that we are doing this kind of analyses. We would love to do all the virtual water implications that happens after this crop diversification, but we are scared that we might not have the right kind of data set to make an informed judgment to tell the policy measure that this is the kind of diet that could be prescribed based on the water deficit patterns.
The bottom line is that 80% of the increased demand for 2030 on food around the world is going to come from diet.
That's true.
Not from the number of people, it's just everyone who wants to eat eggs and milk and bacon for breakfast. 80%, and that India and China are that's really where a lot of that demand is being from. When you're talking about marketing,
I mean, there are some of the challenges. I mean, obviously population is a major driver when it comes to virtual water implications of it. And seriously, we are not sure that the country is open to this kind of policy initiative, leave alone the virtual water diet implication that we have any. So we are trying to take baby steps, one step at a time. If the government is able to take this kind of results, we could go a step further and say that here, it has huge implications for diet. So you're right there, but we are constrained by the right kind of data sets. To do only this kind of analysis, it took us months just to get the right kind of data. Because to be able to say that huge amount of countries already under stress is a major statement to make. So it's only after informed judgment that we can prescribe any kind of right diet measure. And seriously, we are not looking forward to doing that. This is the first stage. Let the government react to it, and then we would do something else in regards diet implications. So I hope it answers your question.